Okay, the world is composed of shapes. And if you're ever going to have to be able to figure out the volume and the area of all these different shapes that exist in reality, you got to start somewhere. It's never about something just being one shape. I mean, something just being a rectangle, something being a triangle, or something being a circle. You're going to have things that are combined. And you'll see that as we go through some of these problems in here for this unit. So, when we look at composite figures composed of two or more shapes, to find the area of these composite figures, you find the area of the respective shapes and add them together. Alright, so let's talk about the different shapes that you could encounter. Alright, so next slide. Well, you could have a square where, to find the area, it's side squared, right? Because left side times top is, is going to be what the area is. If for a square, if this is 2, then this has to be 2 too, right? And 2 squared is 4, so you'd have 4, right? Again, area, length times width. So if this is 4, and this is 8, then the area is going to be 32 square units. And if you notice here, a parallelogram is roughly the same thing as a rectangle, except we're talking about the height here. The height. So you get your base and your height. All right, and those would be the different things that they would give you to be able to figure out those solutions. For rectangle, squares and rectangles, the horizontal side multiplied by vertical side, parallelogram. Again, you can read the stuff on your side. Right, so the next slide. Let me get rid of this pointer. Next slide. No, I'll erase on the next slide. All right, as I'm erasing here on this slide here, again, it's not too easy to forget things here. Now, if I told you before, when it comes to a triangle is nothing more than half of a rectangle. And so you got to realize that. And so always realize that if we have a length and width, it's the same thing as saying a base and a height. And so it's half of it. And why height? Because again, it's like with the parallelogram, the height is the big thing that matters. Okay, we go to pointer again, go to the next slide. All right, trapezoids. It has a formula as well. Again, let me go back up, previous slide. If we talk base 1, base 2, right? And so here's base 1, here's base 2. And so you'd add that distance and that distance, and then you multiply it times half the height. So that's one of those other things in there. Likewise, sometimes if you can't remember the formula, if they give you a way to figure out the triangles, then you just add this triangle, and the rectangle, and you get your answer. So a couple different ways you can do it. All right, back to my pointer here. Let's look at our first problem. All right, boom, and 5. All right, so again, this talk speaks to the whole part about when we talk about things being composites here. So if you look at this, it's almost kind of like an ice rink, right? And so if you think about it in that respect here, right? Think about what we're working with. So, I figure out why I won't do that. Let's see. My next, go to slide 6 here and see if I can go back here. Boom. All right, boom, boom. Okay, good. All right, so 2 semicircles equal 1 whole circles. All right, we're running out of time here, so I'm going to stop here and then I'll talk solutions to these problems in the next video. All right, out here.